Good morning, grade 9. Now, inshallah, we are going to make a revision for the sessions that we studied before and explained it, which is called How Atoms Differ. Okay, I hope that you will enjoy, inshallah, with this revision. Okay, let's begin. This session was called How Atoms Differ. How Atoms Differ. As the number of protons and mass number define the type of atom. As we said before, that any atom has two numbers. The number below, which is called atomic number, and number above, which is called mass number. And we said that what's meant by atomic number? Do you remember, Hussam? What's meant by atomic number? Do you remember?
No.
Okay. Atomic number means number of positive protons or number of negative electrons. Number of positive protons or number of negative electrons. So it means that number of positive protons must be equal to number of negative electrons in any atom. Okay, this is atomic number. But what about the mass number, the number which above the element? Mass number means that it's a sum of protons and neutrons. Sum of protons and neutrons of any atom. So any atom will differ in the atomic number and mass number. Okay, any atom will differ in its atomic number for another atom. Okay, so let's begin. The vocab that we studied before was periodic table, and we explained the meaning of periodic table, and we said that it includes all elements that we know till now, okay, and the number of this element till now is approximately 116 element, okay. This element includes metals, non-metals, noble gases, and transition element, okay. And this periodic table also has stable element and unstable element, okay. But the vocab that we are going to explain it for again will be number 1, atomic number, number 2, isotope, number 3, mass number, atomic mass unit, which has symbols AMU, and atomic mass. First, the questions that we studied, and we are going to make revision for second time. Number 1, how is the atomic number used to determine, to identify an atom? Number 2, why are atomic masses not all numbers? Number 3, given the mass number and atomic number, how are the numbers of electrons, protons, and neutrons in an atom calculated? Okay, let's begin. This is hydrogen as example. This is a symbol of this element. H means that it's hydrogen. Chemical name, it's a hydrogen. It's atomic number and this mass number, but in this image, okay, he reversed the two numbers. He reversed the two numbers as he wrote atomic number above the element and mass number or atomic mass below the element, but it's a vice versa. Vice versa. Atomic number must be below the element, while mass number must be above the same element, okay? As information only. So, atomic number, what's meant by atomic number? Each element contains a unique positive charge in their nucleus. As the number of protons in the nucleus of an atom identifies the element and is known as the element's atomic number. So it's the meaning of atomic number. Can you read it, Sam? Can you read the meaning of atomic number?
Atomic number. Each element contains a unique positive charge in their nucleus. The number of protons in the nucleus of an atom
Identifies
is known as the element's atomic number.
It's okay. So after that is a problem. How can we get atomic number, number of protons, and number of electrons for this element? As example, this element has B. It's called lead. Atomic number its atomic number is 82. So what about number of protons and electrons? Can you answer me, Hassan?
Atomic number.
Yeah. What about the atomic number? Atomic number of this element is 82. So what about number of protons and electrons of this element? Equal what?
Equal 8.
8. Why
Yes.
8? Why 8?
Because I think the another element it's 8. I forget.
No. What is the relation, Hussam, that I explained before? What is the relation between what? What the relation between atomic number and number of protons and electrons? What's the relation between them?
Sorry, mister, but I always forget.
Okay, the atomic numbers means what that you explained before and you said before. Atomic number means the number of positive protons which equals to number of negative electrons. It means that what? It means that the atomic number is the same number of protons, also is the same number of electrons. Okay, so if you have atomic number of lead element is 82. So what about number of protons and electrons for this element? Will be what? Will be what, Hussam?
Will be
Will be also 82. Will be also 82.
yes.
Yes, I said before that atomic number is the same number of protons, alaykum assalam, and the same number of electrons. So if this element has its atomic number 82, so the number of protons and number of electrons will be 82 also.
Yeah.
Understand, Sam?
Yes.
This is the relation between atomic number and either number of protons or electrons as the same. Okay? Okay. Thamer, can you answer the question number 2 in this table? Thamer?
Yes, mister.
Can you answer the question number 2 in this table? This is element. Okay? Has no atomic number. Has no number of electrons. But it has number of protons equal 8. So that I said and explained before. What is the relation between each atomic number, number of protons, and number of electrons? If the number of protons was 8. So what about number of electrons and atomic number of this element will be what?
Mister, I don't know because just I come. Just enter the session now.
I think this session is revision for sessions that we explained before. Okay, and I said before, Tamer, that is the relation between atomic number and number of electrons, protons, that is equal. And the atomic number has the same number of protons and also same number of electrons. So if you have 8 protons, so what about atomic number and number of electrons for this element will be what?
8.
Yes, will be 8. Will be 8. As atomic number equals to number of protons equals to number of electrons. So if the number of protons would 8 would be 8. So the number of the atomic number and number of electrons also will be 8. Okay, thank Bassami, can you answer the question number 3?
Yes.
If the number of electrons in this element was 30, so what about atomic number of protons? It will be what for this element?
I just came in, mister.
What?
I just get in the revision. How, mister?
I explained with Tamer, and I think that you arrived before explanation, after explaining
Yes,
this
mister.
question for
Sorry,
Tamer.
mister. Sorry, can you explain again?
Atomic number of any element is the same number of protons and also same number of electrons. So if you have 30 electrons in this element, so what about its number of protons and atomic number of this element also? It will be what?
You said the same number, right?
Yes, same number. So equals what?
30.
Yes, equals 30. As atomic number is the same number of protons and
Yes.
same number of electrons. So if the number of electrons was 30, so the number of protons and atomic number also will equal 30. Okay, thanks. So
Okay.
this is the problem, and this is answer to this problem. After that, this is called isotopes and mass number. Isotopes and mass number. Listen, please.
Usually, the relative abundance of each isotope is constant. Example, in a banana, 93.26% is potassium 39, 6.7 mass number. All atoms of a particular element have the same number of protons and electrons, but the number of neutrons in the nucleus can differ. Atoms with the same number of protons but different numbers of neutrons are called isotopes. In nature, most elements are found as mixtures of isotopes. Usually, the relative abundance of each isotope is constant. Example, in a banana, 93.26% is potassium 39, 6.73% is potassium 41 and 0.01% is potassium 40. In another banana or in a different source of potassium, the percentage composition of the potassium isotopes will still be the same. Isotopes containing more neutrons have a greater mass. Isotopes of an atom have the same chemical behavior.
So after this explanation, we observed that isotopes of an atom have the same chemical behavior. And isotopes containing more neutrons have a greater mass. More neutrons and have a greater mass. So the differ between the same element in its isotopes will be in its atomic mass. But atomic number is a constant. But they will be differ in atomic mass only. So the isotopes of element means what? Isotopes mean the element that have the same atomic number, but they differ in their atomic mass. Differ in what? Differ in their atomic mass. Okay? This is the explained before. As this, isotopes and mass number. The mass number is the sum of protons and neutrons in the nucleus. Mass number is the number of protons and neutrons in the nucleus. So this is potassium 19, 19, 19. But its atomic number 39, here 40, and there is 41. So we can observe that potassium element has 3 isotopes. Okay, that's equal in their atomic number, but they differ in their atomic mass due to difference in the number of neutrons. This is potassium element has 19 protons These 19 protons, these 19 protons, but these 20 neutrons, and these 21, and these 22. So they differ in the number of neutrons due to their difference in their mass number. Okay, this is a problem about this element and its atomic number and their mass number. Okay, and this is the name of isotopes: neon, calcium, oxygen, iron, zinc, and mercury. This is the mass of atoms. But we said one atomic mass unit, AMU, is defined as 1 over 12 the mass of the carbon 12. 1 over 12 of the mass of carbon 12, as mass of electrons equal this, protons this, neutrons this. So we will observe that the mass of electrons is very, very, very small, that can be neglected. But we can't neglect the mass number of protons and neutrons. Okay? So 1 AMU is nearly, but not exactly, equal to 1 proton and 1 neutron. This is the weight, mass of atom. That the atomic mass of an element is the weighted average mass of isotopes of that element. This example about isotopes, a mass number, percentage of each one. This is the question that we studied. How is atomic number used to determine the identity of an atom? Why our atomic mass are not whole numbers?
Review. Essential questions. How is the atomic number used to determine the identity of an atom? Why are atomic masses not whole numbers? Given the mass number and atomic number, how is the number of electrons, protons, and neutrons in an atom calculated? Vocabulary. Atomic number. Isotope. Mass number. Atomic mass unit, AMU. Atomic mass.
It's okay. So after this, we are going to answer question of this lesson about the macro health science. Okay. Okay, Hussam, can you answer the first question?
Yes, mister. Why
Okay.
are all atomic masses not nearly whole numbers?
Yes, why are all atomic masses not nearly whole numbers, as it has percentage? Why? Choose the best answer.
Because A.
Number A, mass
Yeah.
of all electrons in the atom. Okay.
No. This yes A.
Okay. Number 2, Bassami, can you answer the question number 2?
Yes, of course, mister. The atomic number of an element is defined by its number of
The concept
Mister,
of atomic
I
number.
need hint, mister. Look, there is hint.
Yeah, this is hint. The particles are contained in the nucleus. These particles are contained in the nucleus.
Nuclei, yes.
Yes, so the atomic
D.
number D.
Mm-hmm.
Okay. Thamer, question number 3. Thamer.
Yes, Yes, mister, yes.
Question number 3.
The sum of the protons and neutrons are nucleus, and a nucleus is
What is the concept of sum of protons and neutrons?
the atomic
Ethan.
number.
Atomic
Atomic
number.
number.
Okay. Number 4, Hussam. Sam, number 4.
Which is the following is true for any atom? Atomic number equal number of protons equal number of electrons. Atomic number equal number of neutrons equal number of electrons.
Okay,
Mass number.
which is the best answer? Can you read?
Yeah.
By your eyes and choose the best one, best answer.
The best is I think B.
B. Atomic number of neutrons equal number of electrons. Okay. Bassami, question number 5.
How is the atomic mass unit AMO defined?
Yes. How is the atomic mass unit defined?
C.
C. Okay. Let's go. I think
wrong,
that.
right, mister?
Yes, it's wrong. I think
no,
that.
No, I want to change.
Change to what?
To A.
What?
To A, mister. Letter A.
Letter A. It's okay. Thanks. Let's grade this test. Okay, all these questions are false except the last one of Bassam. That's the first one is because atomic masses are weighted to average the mass of all naturally occupying isotopes. Number 2, protons. Okay, atomic number of protons. Sum of protons and neutrons, mass number. True, atomic number equal number of protons equal number of electrons that I explained as examples in this session. And last one, 1/12 mass. Okay, thanks grade 9. Thanks for your participation and happy Ramadan for all. Okay, see you soon inshallah in the next chemistry revision and goodbye.